So the empirical formula gives you the simplest ratio in which the different atoms in a molecule is represented. So it's not the same as the molecular formula. It tells you that for each hydrogen, you have 2 oxygens. This one is the other way around. Okay. But you need to understand that it is the simplest ratio in which the atoms are. Okay. So byvoorbeeld as ons gaan kyk na hierdie water ene, is 'n gunsteling ene. But water is a bit difficult because the molecular formula and empirical formula of water is the same. Maar kom ons gaan kyk na waterstofperoksied, wat hierdie ene is. That is the molecular formula of hydrogen peroxide, né? Julle het al van hom gehoor? We've heard about this one. What would the empirical formula of hydrogen peroxide be? Onthou nou toe julle in graad 8 verhoudings gedoen het, dan het ons gesê jy vereenvoudig hom mos so ver as wat jy kan. Dit gaan 1 tot 1 wees. So the empirical formula of hydrogen peroxide would be different from the molecular formula. This is the molecular formula, meaning that if we are looking at the actual molecule of hydrogen peroxide, there will be 2 hydrogens and 2 oxygens bonded chemically to one another. Maar as ons gaan kyk na die empiriese formule, wat het nou gebeur? Goed, kom ons probeer weer. Hardloop ons deur die hele slideshow, klaar. Pak weg, gaan huis toe. Okay, but when we're looking at the empirical formula of this one, it will be H1O1. Ons skryf mos nie die ene daar nie, maar ek wil julle moet verstaan, dit beteken, as ons hom gaan teken, with the ball and stick method, then that will be it. The yellow ones are the oxygens and the blue ones are the hydrogens. So sien julle, daai ding se formule is H2O2. But for each oxygen, we only have 1 hydrogen. That is the simplest formula with which they are represented in that molecule. So vir elke 1 waterstof, het jy 1 suurstof en andersom. If we're looking at water, wat is die molekulêre formule van water? H2O. Can that be simplified further? No. So the empirical formula will be the same. Because for each 1 oxygen, we have 2 hydrogens. And in reality, we have 1 oxygen and 2 hydrogens. Okay, goed. So dis basies wat die verskil is tussen empiriese formule en molekulêre formule. And I'm going to talk you through the whole calculation. So at one point, we stop when we're doing empirical formula. But I'm going to talk you all the way through. So they say, when you have to calculate the empirical formula, assume that you have 100 grams of that sample. So hulle gaan vir jou sê, nou maar sê, die molekule bestaan uit 24% magnesium. Then you take it as, I have 100 grams of that. In other words, 24 of those grams are magnesium. Okay. So jy vat dit en jy sit dit om na gram toe. Moet dit vir jouself moeilik maak nie, moenie werk in 'n 10 gram nie, werk in 'n 100 gram, want dan is jou persentasie mos net daar. Okay. Then you calculate the amount of moles of each. We did this last year as well. Do you guys remember this? No? And you represent it in a relationship. And then you look for the smallest one and you divide all of them by the smallest one. Now, ons gaan nou maar uitkom by wanneer hulle hierso by 1,5 en so is. Okay, because sometimes that's step 5. If you divide it by the smallest one, you'll get numbers like 2,00008. Make that 2. Okay, but if you have 2,489, then make that 2.5. So you can't round up or down from a decimal that's close to 0,5. Okay, dan moet jy daai half daar neerskryf. Maar sê nou maar jy het gedeel deur die kleinstes en jy kry iets wat baie naby aan 'n heelgetal is rondom dan af. Okay. And then you multiply to get to whole numbers. Gewoonlik gaan jy of maal met 2 of in party gevalle gaan jy maal met 3 en dit is die empiriese formule. And we'll talk about how we get from that to the molecular formula now. So what we do is hulle sê vir ons dis die voorbeeld onder op bladsy 193. They say that in this compound it's made up of 73.9% mercury and 26.1% chlorine. Nou gaan jy gaan en jy sê ons maak asof dit beteken ek het 73.9 gram kook en 26.1 gram chloor. And for each of those you calculate the amount of moles represented. So jy gaan net sê die aantal mol kook is daai massa wat jy nou om as gevat het gedeel deur kook se molare massa, which you get from the periodic table. And that gives you this. Okay? Vir chloor doen jy dieselfde, so jy gaan sê daai 26.1 wat jy gekry het van die persentasie af, gedeel deur die 35.5 wat vir jou gee 0.735 mol chloor. And this you write down in a relationship like that. Okay. Almal nog by? Now when you're looking at that, which one is the smallest number? Daai ene, né? So we're going to go and divide both of those by 0.386. Kyk gou vir my. 0.735 gedeel deur 0.386 gee vir jou 1.904145. Do you guys understand that I'm going to take that to 2? Yes.
So, hulle dan bo gekry 0.368 maar reg onder 0.86.
Ja, niks verbaas my nie. Gaan nou ook maar verander. Kyk, kom ons deel hom deur die regte ene. Hy gaan nog 'n groter desimaal hê dan. Ja. So hier kry jy 1 tot 1.997. So wat gaan ons daar skryf? 2. Stem julle saam? I'm just going to write down 2 there because that is basically 2. But let's say this was 1 to 1.486. Ek kan nie net sê daai is te significant grootte om dit net weg te gooi of net op te rond. So then you would simplify it to 1 to 1.5. Kan ek dit los as 1 tot 1.5? No, those have to be whole numbers. So then I'm going to change it to 2 to 3. Okay, het jy long. But in this case, it means that the empirical formula will be that. Vir elke 1 kook is daar 2 chloor. And coincidentally, I think that is also the molecular formula for, yes, it is. Okay. Goed, nou gaan ons verder gaan na die molekulêre formule toe. So, all of those steps, if they ask for the empirical formula, then you stop there. Almal by. That's where you stop for the empirical formula. Now, in the next step, they will tell you the actual molar mass of this. So, whatever it is, they'll give you the actual molar mass.